Yeah, so Mahesh, the things that we covered in this section, like mm, this
Is that the
topic,
challenge we are doing?
network Kubernetes policy.
Okay.
So the task, I mean, there is a challenging task, right? Some ports, how to
Yeah, you are
communicate
given.
in. Yes, yes,
You given challenge, right? That one.
yes.
Okay.
I will showcasing how the network policies that we implement within our Kubernetes cluster. Okay.
Okay.
So consider this is a Kubernetes cluster. Okay, the cluster have two parts. One is master and one is worker.
Okay.
And coming to worker node, okay, the worker part we have different components like node, node 1, node 2, and node 3. So what is node actually? Any idea? Mahesh, Amol, I'm audible, right?
Yeah, I can answer if you want. Or
Hmm. I'm just
generally, like in a network of computers, like a physical machine was referred to as a node. On like supercomputers, it was just like a lot of computers put together, networked together.
yes,
And
yes,
individual
right.
computer was referred to as a node. But when
No.
it became virtual, that distinction kind of started to blur a little bit. It may not be a physical machine; it's a logical machine, maybe.
Yes, yes.
But when you put images of Docker inside, that blurs that notation even more. But I think the simplest way to think of it is like a computer on the network.
Right. When coming to Amazon, we can easily, or maybe we can simply say it's a easy to machine.
Easy to. The node, are we going to use as a VPC? It's a connection between the server and that intranet.
Sorry.
No, my question is, are we using node as a connection between the server and that intranet? Like because we will be
Which
having
server? Which server?
in the local server and the external server.
I didn't get you for the, I
No,
mean, the
no, no.
server part.
My question is, yeah. See, we have server in some so any data center like Virginia, Mumbai, anywhere.
Okay, okay, got
So
it.
if you want to use that the same server in different region, there should be some the VPC, correct?
Yes.
Or if you want to connect, there are we have a three multiple server in the Virginia center, server A, server B, server C. There should be a connectivity between the three to access the web server. Like one is a database server, one is web server, another one is a different server. So there should be a connectivity between these three. We're going to use VPC.
Yes.
So in that way, are we going to use the node? Because node we can use it in a different manner. Like a data structure we can use.
Got it, got it. Coming to Kubernetes, right?
Yes.
So when we creating Kubernetes, we will create a data center actually. For example, this Kubernetes have, okay, this Kubernetes cluster have a VPC, subnets. VPC have a IP range, okay. Subnet have their own IP ranges and route table, load balancer, all things created when we creating this Kubernetes cluster.
Okay.
This is managed. That's why we didn't bother about these components because
Okay.
this will created uh, automatically.
Okay.
Got it.
Got it.
Yeah. So yes, we in this case we have a Kubernetes cluster and we have three EC2 machine. That is three nodes. Okay. So our requirement is we have a YAML file. Okay, we have a YAML file. That YAML file the Kubernetes section, we need to, I mean, you refer too much, okay? Like when we go into interview, we are facing Kubernetes architecture questions or components, then some tech inside, like the commands, the services, all the things they will ask. So this is a YAML file, okay? We have a YAML file. This is a pure cluster, no pod or no container, okay? We just configure. So we have a YAML file for a deployment. So when we pushing from our local machine, this YAML comes to the API server. Master part have some components like APIs, API server, etcd, controller, and scheduler. These are the components inside the master part. And coming to worker part, we have three nodes, okay? So the YAML go through the master and we have a scheduler and controller. So the controller and scheduler will checking the best node, okay? Comparing with these three. So it will pushing to, I mean the YAML pushing to the corresponding node. So consider the YAML file, we have a replica set 3. That means we need to create the same application in 3 instances, okay? So the first instance go to here. It will create a pod and a container. Got it. This is a pod and this is the application container. So the replica is 3. So the next one go to the same pod or these things managed by the master pod, okay? So it will definitely go to the checking another node like that. So it will go to the second node. Same application, okay? But a identical version. Next pod created and the container created. Replica is 3. So the next one maybe go to the third one or second one or first one. So I just showcasing it's going to third one. So it will create a pod and container. Okay, pod is its definition is it's a single small unit inside a Kubernetes cluster. Okay, because this master part can't direct talk with the container. That's why we create a pod. So pod to pod, they can manage. I mean, they can communicate with the pod. So that's why we create pod in node. Okay. So by default, these pods, okay, these pods can talk with the other pods within the Kubernetes cluster. So this pod can talk with this, and this can talk with the. Sorry, this is identical. Okay, leave the identical versions. For example, we have one more deployment. Okay, this is a front-end application. Consider this is a front-end application. That front-end application have 3 pods. So not front end, okay, this is a different application, like this is a different client application, like application A. So we have another application we need to deploy. So that is, again, we need to create another YAML file and push. So it will create another pod here and container same way. That replica is only 2, okay, so it will create 2 pod in 2 different node and 2. This is pod and this is pod and this is container. Okay. So by default, these pods, all pods can talk each other. That's a scenario, okay, by default. So this pod can talk with this pod. This can talk with this one because these are entirely different pods, okay. So we need to secure our running pods. That's why we are using Kubernetes network policy. So after we applying the Kubernetes network policy, we can say only the specified pods can talk with each others. Got it? For example, in this case, this pod can't talk with for example, this pod can't talk with the other pod, then we can apply a Kubernetes network policy and configure the thing. So this pod only talk with the specified pod, not all the pods. Okay. So I will remove the entire thing. So I will briefly showcasing the Kubernetes policy in our challenging lab. For example, coming to our challenging lab, we have 3 pods. This is A, this is B, application B.
You mean the uses of nodes is creating a connecting between the parts from the different server?
Right. So we have 3 pod, okay. So this is A pod and this is application B and this is application C. So the requirement is the application by default all the pods can talk each other, okay, like 2-by connection, like this can talk B can talk A and A can talk B, B can talk C, C can talk B, like that, no restriction. So after applying the Kubernetes network policies, okay, the requirement is we need to create a network connectivity, like A can talk with the B, B can talk with the A, but B can't talk with the C. Okay, C can talk with the A. So this is a requirement. Okay, so this requirement we need to use the kind like Kubernetes network policy. And for network policy, we have a separate YAML file, and inside the YAML file, we need to choose the network workflow, the incoming traffic, all the things. And we need to mention the ports as well. Which port needs to talk with which port, like that. Got it. So applying the network policy, we can sort out the things like this. For example, this is considered this is a front-end application. And this is the backend. This is the database. Got it. So the front end can't directly communicate with the database. That's a requirement. So only the B port can talk with the database. No other ports within the Kubernetes cluster not connect with the database. Only incoming traffic. Okay, we called as ingress in Kubernetes. So the front end application can talk with the B, I mean the backend. Backend can talk with the A, no problem. And the front end can't talk with this database pod. Only the B can talk with the database pod. So these are the similar scenarios in real world cases, like securing the database, like using network policies. Then we can quickly jump into the lab, right?
Yeah.
Any doubt? Hope you understand the usage of network policies within Kubernetes cluster.
Yes.
Amal and Mahesh.
Yeah, I got it.
Mhm.
We have to create 3 instances, right? One is for master, one is for slave node.
No, I am
Who is for slave?
not self-hosted. I'm just to go to commissioning EKS. So now bother about the not count and all things. So I will I need 3 worker nodes. So I will 3 or 2 you can choose.
Yeah, that's right. We have to create a total 3 instance, right?
No. This instance for managing Kubernetes cluster, just taking a machine.
Okay.
If we have the privilege, then we can use our own local machine. But this is for managing Kubernetes cluster.
Okay.
Managing in the sense of, I mean, like administrating. Got it or confused? I will. For example, we have a Kubernetes cluster. Okay, this is a cluster, right? EKS. I'm audible, right?
Yes, you're audible.
You're audible. I think you're sharing a different screen.
Yeah, sorry. So this is a EKS, okay?
Yes.
So this EKS in a cloud, right? Like AWS account.
Yes.
So this is one service EKS. We configured and we install EKS. So we can see the cluster is running inside the AWS account. So two-way or three-way we can connect with the EKS. One is locally. Local means our own laptop. Okay. So the prerequisites are, first we need to install AWS CLI, local machine. Then install EKS CLI, EKS CTL, then kubectl. These three things we need to install inside our local machine. Then we can directly connect with our Kubernetes cluster using the kubeconfig file. Otherwise, we need to create one EC2 machine here. I mean, we have to create EC2 machine within our AWS account. So installing these things, EKCTL, AWS CLI, and kubectl within the EC2. Because in local machine, in my case, I don't have privilege to install these things. That's why I create a EC2 machine and install these things. From this machine, I'm going to managing Kubernetes cluster. Got it? Confused?
Can you repeat this concept? So there is what is the rectangle around the rectangle of EKS? So EKS, and then you have E pointing into EKS.
No. I'm just accessing the EKS that I explained. Like two-way we can, this is a one way. Installing all the components, prerequisites, all the dependency within our local machine. Or we can take a EC2 machine to install these things and from here to manage EKS cluster or here to manage. In your case, if the laptop is personal, then you can do the components installed in this your local laptop. Got it?
Usually in real time.
Real-time local machine.
Oh, we're going to use the EKS in local machine only,
Yes,
not
I
from
think.
the AWS.
No. From local machine. Because for managing EC2 machine, then this is additional cost, right? For accessing EKS.
Correct.
I think we manage, right? Not, I think I install EKS, ETL, all the things in my local machine and using Terraform, or I think so. Today I'm using
Yes,
my.
you use
Yeah.
the managed AWS EKS actually, not the self one.
Okay. This is a managed one, EKS. So real time, we use our own laptop. And what are things that we need to do? Install AWS CLI and kubectl. That's fine.
Taufik, I have a
EK.
question now actually.
Hmm.
So you tell we're going. Sorry, we'll use our laptop. So are we going to use the EKS service in the AWS account or in the outside the AWS account?
That EKCTL, this tool, right?
Yes, the entire EKS, managed EKS service.
This is actually why we installing EKCTL means to create Kubernetes cluster. So
Correct.
create Kubernetes cluster, we need a tool, EKS-CTL. If we have Kubernetes cluster, then we didn't install the EKS-CTL. Just AWS CLI and using the username and password, then we can create a service connection between our local machine and Kubernetes, AWS. Then using the kubeconfig, we can create a connection from our local machine to decide a Kubernetes cluster. Then using kubectl command line tool for accessing our or managing the Kubernetes cluster. I mean the EKS.
Okay.
Confused or cleared?
Yeah, I'm a little confused because I'm not understanding properly. My mistake. For that EKS, it's a EKS managed EKS is a AWS service. Correct.
No, I will explain. You are attending the batch 3, right?
Yeah, this is my first batch.
No. I mean, this is almost done.
Third batch of
Coming.
the year. Third
Yes.
batch of the year.
I think I am planning to after 25 start batch 3 from scratch. I mean, from basics.
Yeah, I will attend that one too.
Okay. So I will explain. Kubernetes are a different way of we need to deploy. When coming to AWS have their own Kubernetes cluster. There's a service that is EKS.
Correct.
Fully
That's
managed by, we called as this is managed one.
managed service. Correct.
Managed by AWS.
AWS.
Okay. Then
Got it.
this is costly when comparing to self-hosted.
Self-hosted.
So
Correct.
coming to self-hosted, we are the one who need to choose the master machine, how many EC2 we need, like all the things we need to set up. Like in this case, we take 3 EC2 machine, okay? EC2, and EC2. And we deploy, I mean, installing the master part, then we
Worker
keep
part.
these 2 machine as worker node. So we will install
Got
those
it.
components and we will adding this machine to the master part. So this is a master and this is a worker.
That is my question actually. We are using that managed by EKS services or the self-hosted we are using in real time?
Yes, I explained that thing, right? Amol, I hope you.
Yeah.
No. You explained. Understood. My question is, in real time scenario,
Yes,
many of the companies.
I mean the real time scenario I explained.
Which one they use?
Amol, can you explain which scenario we use managed and self-hosted?
So self-hosted is cheaper than
I know that is actually. See, when we compare to the AWS EKS, self-host will be cheaper because that we'll be handling. So when it comes to EKS, that is the service is given by the AWS. They will charge us. My question is, as a AWS DevOps engineer, so if you join any company, the company is going to use the EKS or self-hosted or EKS, AWS
depends on how
EKS.
much money the company has, I guess.
Yes, yeah.
Depends on the corporate strategy.
Yes.
If they have the money, they're successful in the market, and they has the value in the paying Amazon, then fine. If they don't see the value in that, they want to have their own. Sometimes people want to keep data, the control on their data. They don't want to put it in the cloud. There are all kinds of reasons. Whatever from the higher up, you will get a input of what they want, right? If it's your own company, you can decide based on your own judgment. It's a
Yes.
different choice, right? You go into the restaurant, what are you hungry for?
That I got. I understood. Taufik, in your company, which one they'll use? Either TK, AWS EKS or self-hosted?
Yes, I will explain. When we using self-hosted, okay, most probably self-hosted will use
for the small companies like
yes,
small income
not I think
generating
it's
company.
mostly nowadays mostly using for development. Dev environment. The
Okay.
self-hosted or Minikube. Minikube is another version of Kubernetes. We can simply configure Kubernetes cluster within a EC2 machine. This is the
Okay.
third one, okay? And the
Mm.
self-hosted is some companies self-hosted use for very small application.
Correct.
Okay. And coming
Yes.
to a normal scenario, like uh, it's a complex application or some high application, then we must go to the managed cluster like EKS or AKS, Azure Kubernetes Cloud Service. AKS, then GKE, Google Kubernetes Engine. That is
Yes.
managed by Google. This is managed by
Google.
Azure. This
Azure.
is AWS.
AWS.
So
I know.
yes, coming to CI/CD, mostly we use EKS or AKS or GKE. And this self-hosted small applications and development phase.
Mhm.
And Minikube is a small version of Kubernetes. Okay, we can just take a EC2 machine, only one EC2 machine, and inside the EC2 machine we can install the Minikube and the components. So we will get a exact Kubernetes cluster, like work with the kubectl commands, like deploying application or all the things.
Okay.
So coming to EKS, we didn't bother about any dependencies like from VPC to load balancer. From here, we have the one choosing VPC, load balancer, all the things. Got it?
Yes.
Somebody was telling me once that the cloud people did a lot of marketing and persuaded everybody to go on to cloud, but now like the costs are a lot, and everybody's also like the security issues are there, and sometimes the people are like now thinking of having some in-house servers too, like they don't want it all in the cloud. It's like the pendulum shifts, right?
Right.
Things change over time. But it's interesting that they do development on their own network machines, because probably it's not worth the cost of renting those cloud machines, right? Like every developer probably has a laptop or something. They can just work on the code and have one server for pushing it to or something, or using GitHub anyways, right?
Yeah, those things you can use it locally, but when it comes to data center, they have to go for rented only, I guess.
When it comes to data center, what?
Yeah, when it comes to data center, they have to go by either AWS or
Yeah,
Oracle,
yeah.
like Google, because
You
there
know,
will be.
you also asked a good question a little while ago. I didn't get the gist of it, but I forgot what you asked. But the question before this, I think, was a good question you had asked.
I forgot. It's regarding.
He was on the. I forgot what we asked also. I forgot what we were talking. It was just before he started drawing those diagrams where I'm from the laptop going into
Yeah,
EKS.
I was telling. See, the node we are going users of node is to the creating a connection between the different, I mean, pods between the different instances, like different server. Correct me if I'm wrong, Taufik. So that is the way node we are going to use. Correct? So in the same way, we have a Virginia center or Mumbai center. We have different data center where we will be having one data center database, one data center will be Apache server, WebEx server, another is having a different one. So if you want to connect between these three server. So there should be a connectivity. So when the connectivity should happen, there should be a VPC, virtual private cloud. We should create a VPC between these three.
Right.
Which between the three nodes?
Not node. See, node is a the uses of node is to creating a connection between the pods. Like we have three different server. In this server, we are creating a YAML file. So in the three server, we have a YAML file. There should be a connectivity between the three YAML file, three pods. So we are going to use the nodes to create a connectivity. Correct, Tawfiq?
Right.
Isn't it a basic computer networking? You need a computer to be in the network, right?
This is not the basic network actually. This is talking about that application side. I am talking about. See, we have take an example of one data center.
I will explain. Like
Okay.
my screen is visible paint, right?
Yeah.
Yes.
So the requirement is we need to create a VPC, right? Sorry, we need to create EKS. So I will showcase the background, okay, before creating EKS, because here you can see from the stack, this is actually a template there, okay. So it will create a VPC, all the things. It's not mentioning the VPC. You can see here the subnet 1, okay, D, 2 subnet we use, I think 1D, 1D, okay, 1C and 1D. One VPC also there, okay. So coming to the real world scenario, I'll showcase what actually happening behind. Before creating the EKS, there is created a VPC and created subnets. So these two things are done. Some other components are there, okay, like inter gateway, route table is there. It will create these that components as well. And coming to the node, okay, the EKS node, that nodes belongs to each of the subnet, availability subnets. So this subnet, the VPC region is US North or something, okay. And each subnet is different availability zone. For example, this is in Florida, and this subnet is in somewhere else like New York City or anywhere. Consider like that. If any city is going down, our application or the instance is running in another availability zone. And the application, that pod or the things under the corresponding machines. This is our replicas 1 and 2 like that. If this machine is down or the entire location is down or any issues, our application and other instance will up and running in another region. Sorry, another location. Got it. This is not Kubernetes cluster and all the things,
Yes.
that thing. Only the machines, like how the machines running. So we take these machines and creating the Kubernetes cluster. So actually the machine located in the same locations like that, like this. Got it. Like, any doubt?
So Kubernetes.
Yes, Amol, once again. Come again.
So yeah, the Kubernetes is not aware of geographical location of machines. Is that what you're saying?
No, it's aware. You can see here in the logs. See, here the setting available is on. Use 1C, 1D. Subnet for use 1.3 and the IP 192 series IP we creating. Got it. Any doubt? Actually,
So Mahesh was saying the purpose of node is to connect the pods, because the pods can be in different. You can make pods inside the nodes, right? And they'll connect to the nodes.
Mahesh, you, I mean, I clarified, right? Or still confused? Mahesh, you're there?
Yeah, I got clarified.
For
Hello.
example,
Yeah, I am there. I'm audible.
Yes, yes.
No, my question is, see, we have some Arizona, Florida, we have data center. In the data center, there are two different server. One is
Yes.
a backend server.
This is one. Sorry.
One is backend server, and another is database server, and another web server.
This is Kubernetes scenario or normal scenario?
Normal scenario I'm talking.
Okay.
So normal scenario. We have 3 server in the Arizona. So when outside so I'm sitting here using my computer, I want to access those one. Through intranet, right? Through internet.
Okay.
So when there is a connectivity should get outside. I mean, how to connect that the machine from the outside the vendor, like outside the people.
Outside the people's means?
I mean, so I want to connect that one. The machine
You
is in Arizona.
You need to connect with the one of the server, right?
Yes.
We can connect.
Your voice is breaking.
Yeah, now it's clear, right?
Yes. I can connect with the internet. Okay. So if the same thing with the different server, there should be a connectivity between the different server in the same region, same data center. How it will get connect? Is that through VPC?
Right. For example, we have 3 server, okay?
Yeah.
This is 1, this is 2, and this is 3.
Okay.
Each one in different location, right? That's the scenario.
Yes.
But one region, right?
Yes.
So we can consider this is in same VPC and different subnet, right?
Yes.
Okay. So the first question is you need to connect to these machines, right?
Yes. I mean, connect to this machine in the sense. So there are 3 server. We need to create a connectivity between these 3 server. So because the backend server is going to access the database server, and the front-end application web server is going to access the backend server.
Simple scenario, we can use the route table.
Okay.
That's why we use your route table to routing the traffic between these subnets.
Okay. What is the VPC role in between here?
Inside the VPC, these components like subnet, route table, and all the things. For example, this is a region, okay? Indian region. Okay. So we created our data center application, all the things there, like application. This is a front end, this is back end, and this is a database. Okay. So for each subnet, we have route table. Route table 1, route table 2, and route table 3. So inside route table, we create a routing for example, this A can talk with B. So we create a route here and put the IP of the machine or the subnet. From there is 2 options there, the destination and the target. So the destination is A and the target is B. So A can talk with the B, like that.
Okay.
So, for example, some other machines in some other different region. So there have their own VPC there. Okay, some machines are there.
Mm.
So region to access this is VPC to VPC connection. Okay, so some machines are here, or some users are here. So they need to connect with these machines. So we can use VPC peering, connecting with the two VPC peering. And coming to VPC peering, there is again root table configuration there. So the root table configuration, we will create, create the correct connectivity from the VPC to the required VPC. For example, this VPC, there is a lot of resources there. Okay. So only we need to specify the resources that we need to talk with the other VPC. So this VPC in other region like US or anywhere, Canada, like that. This is purely in Indian region.
Okay.
So how we connect to the mission using PuTTY. Only we need the mission's PEM key
Public
and
IP.
public IP. If the machine is in private mission, I mean, this is purely private mission, we didn't get the public IP, right? So we need to use some gem server. So some other, in real world, we create a gem server and provide the gem server details to the users. So they will first log into the gem server. Then from the gem to private mission, they can log in.
Okay.
Got it.
Got it.
Okay. Hi, Deepthi.
Hi, sir.
Hey, hi. You joined, right?
Yes, sir.
Okay, okay. We are in the middle of one section. This is purely for advanced. So,
Okay.
yeah, you can continue or you can leave, no problem.
The class is going to begin again from the beginning in from the 25th, so you will get to
Yes, flying. I already informed.
This is the ending of the movie. You can watch it and then start the movie from the beginning again.
Yeah. Okay, then.
Actually, I just joined for introduction how it will be going on, right?
Yeah.
That's why.
It repeats every 3 months. That's why.
Yeah. Okay.
I think it's not introduction, I guess.
I think it was the ending of the class.
Yes. So now it's creating the node group, okay, the Kubernetes cluster.
What topic is going on today, sir?
Today we will discuss, Kubernetes network
Okay.
model.
Okay.
This is a part of
Thank
Kubernetes.
you. Okay.
Hope you heard about Kubernetes, right?
Yes, I know containerizations and all will be the kubectl course.
Yes.
Yeah, I know.
So we are creating a Kubernetes cluster. So it's almost done.
Okay. So I think I have to join from 25 onwards. Before that, I need some. Before that only I can join means I brush up uh, my course. It is possible, right?
Yeah, sure.
Okay.
It's almost ready. Yes, we got the cluster. See, cluster is up and ready, and we have 3 running node. So in this scenario, I will create 3 application. Okay, application A, application B, and application C. So I will show the YAML file. See, this is a pod creation YAML file. So the kind is pod. So the metadata pod A, and the namespace, I will change the namespace.
Sir, here you used instance launch from Ubuntu, right?
Right. Ubuntu is my local machine. Consider Ubuntu is my local machine.
Okay.
Because I am using my company laptop, so I have some privilege issue.
Oh, okay. In
For
AWS also we can use, right?
yes, we can take a virtual machine from AWS and keep that machine as local. That's all. Installing the kubectl, AWS CLI, and EKSCTL. Then we can creating Kubernetes cluster within that machine. I mean, in this machine.
Okay.
Yes.
Tawfiq, I have a question, if you don't mind.
Yes.
I think in case it's out of the topic, today's topic. So in case if at all, if you get a job, if you join the company, initially, what are all the service, I mean, access we have to get it? I mean, what are all the service we need to raise a request for that? To be at least 3+ years experience as DevOps engineer. What are all access we need? First thing.
We will get access. Mostly
For
we will get
AWS account.
yes, for AWS account, we will get the administrator account. Okay. So they will create a user for example, Mahesh, your username, then the credential, okay? They will send the password for accessing AWS account as
Okay.
a administrator privilege, most probably.
Okay.
And then what are the services they are using? For example, Jenkins. So they will create a Jenkins credential for you.
Okay.
Then they will send that credential to you. Most probably that is administrator privilege.
Okay. Okay.
Or else they will create some policies like creating jobs built like that. Then coming to the repository, any repository they have used Git or GitHub, they will share that credential. Then Kubernetes access privilege we will get to manage Kubernetes cluster and all the things. So these are the what are services as per the company, what are services they are used. So as
For
a DevOps
example,
engineer, yeah.
They're using Docker for containerization, or Ansible for configuration management, and they're using Lambda for serverless, and they're doing DynamoDB in that, and they're using S3 as well for bucket. So what all request we need to raise? I mean, I need to ask them. Actually, they will not be knowing that I'm a fresher and I'm learning DevOps here. They'll be thinking that he has 3 years of experience, he knows everything. I should not behave like I'm a fresher, right? Because I'm putting 3 years experience in resume. So I have to behave like I know everything.
Got it. So if they gave the admin access, then we have the privilege to access all the services within Kubernetes cluster. Sorry, AWS.
Okay.
Yes.
Okay.
So as per the company rule, for example, if the employee, okay, the development employee is only accessing to EC2 mission and Kubernetes, then they will create a policy for that. I mean, attaching that policy to the created user, the user Mahesh.
Okay. So initially we'll be working on the dev environment. What access we need for that?
For dev environment, actually development environment is a place where we develop. Okay, I mean,
Correct. I know. Because I worked in the real time in the testing.
Yes.
But in the AWS account, if you want to use the dev environment services, because I know a little bit on the quick site where we can create a report on the quick site in the AWS. I worked on the dev environment one, not the production one.
Okay.
So I raised a request for the quick site. After 2 days, they gave me access for the quick site for the dev environment. So we try to create a report automatically. The quick site will fetch the detail from the DynamoDB, and it will generate the report, and we try to modify accordingly. So DynamoDB will fetch the data from the S3 bucket.
Got it.
So my question is, do we need to raise any other request like environment, dev environment? I have not worked on the server side.
Okay. In my experience, when when I am onboarding the company, they will provide all the access. Like there is a lot of services there, like coming to different environment, different tools there. So there is a lot of we keep a Excel file for saving the credential as well. So that much.
That is for our individuality, for saving credential, but we should not forget, and we'll keep that one.
Yes.
That is different. Sorry, actually, I'm taking out of the topic. Sorry, Amol. Sorry, Deep.
That's okay, because this is all like you have to fake it till you make it, right? It's like a jugaad, basically, like saying you have experience, but you don't really, because the employer will also do background check and stuff. So
Correct.
It's very important. If you have some customer that is paying you, then you can basically, then it will create a track record of like, okay, this is.
Why I'm asking? When I was working as a test lead, we recruited one guy from Hyderabad. He don't know anything about the testing. He don't know single points. He used some proxy, The proxy interview was very awesome. He answered all the questions out of the out. Answered was really impressed us. When he onboarded, he's a zero. That is thing should not happen actually. We immediately terminated him.
Okay.
So basically, I think the important thing is to find some project that you can apply this on, your own project, because I mean, maybe you cannot afford all these AWS bills or something, but you could buy some computers and set up a network and do something to be substantial, like you actually capable of doing the work, right? You train yourself on some project. Lots a lot of open source projects are there. Maybe you find something you can work with. That way, you are more solid instead of just. Which city are you based? I'm in Philadelphia.
I'm in Texas.
So you're far from me. If you're near, I would have met you.
Me too.
Because I think, like a lot of this remotely, you talk over some remote channel, it becomes like it's better to meet people in person a little bit at least. So you get more context of.
I'm trying to get project as a freelancer, but I couldn't get. I tried for the AWS project, but I did not get. I tried to get register myself to get the freelancing project, but I didn't get that one. They're getting only for the development, full stack developer, Java developer.
Right now, it's a little difficult time because the tech has laid off. So a lot of good people are also looking for jobs. Like experienced people are also looking for jobs. But is the previous company that you were with in India, do they have any work you can do remotely for them?
I asked them. They're not ready to know the policy restriction, it seems.
Yeah, I think the day you leave a company, all of a sudden your history, like they don't have they move on, find somebody else and everything. The world moves forward basically.
Okay.
So you studied computers in undergraduate?
Yeah, I'm studying undergraduate. I have experience in testing for 7 years in Xerox technology. And
my screen is visible, right?
Yeah.
Yes.
So this is a phase, okay, different phase that we, for example, when before delivering an application, there are 3 phases are there, okay. So first, you can see this is a node application. So how the developers running the application locally, the first phase. So this is the first phase. Got it. So they will send the application to the operation team. That is a DevOps team. So what will we do? We will create a development pipeline. Got it. So using the same Jenkins, then taking the codes, then analyze with the SonarQube, scanning with the Trivy, then build the application using Docker image. Then again, we scanning the image with the Docker Trivy. Then what we'll do? We will push the image to Docker Hub, then deploy to Docker container. This is the development phase. As a DevOps engineer, we're starting from this phase. Okay, this is same application. We will keep to create a development and pushing to the container, not Kubernetes. So if the development phase is success, what we will do? We create a production environment, doing the same things. Again, we create a pipeline for production. Yeah. Okay. Production.
Yes.
And deploy to not container. This is production. That's why we use any Kubernetes services. So in this case, we use EKS. Again, some new features there. Okay, like again the some updates or new features they added to the existing code. They will, I mean, the developers will run the application locally. Then what we'll do, we will take the same thing in the development phase, and if the phase is successfully deployed to container, then what we will do, we just changing the image in the repo, right? I mean, we successfully deployed one, created another image for the new version or new feature. So what we will do is just update the image name with the tag name, okay, like version 2 or version 3 like that. So just update in the repo. So what we'll do, Chingy will automatically build the production pipeline. So this is the phase simply we follow in real world. So coming to this scenario, they will share the credential for accessing Jenkins, Docker Hub, and EKS, all the things. The repos. Got it.
Yes.
And as per the company rules, different companies have different applications. So they will share the required one to the employee. Similar like. So we can quickly jump into the lab, right? Okay. So in this case, we successfully deployed Kubernetes. And here you can see we have the three YAML file, okay, for the application A, B, and C. This is policy, I will explain. So coming to application A, here you can see this is a simple application and it's a kind pod. So it will create a pod and the pod name pod-a and label, same name we provided. Then the spec, under spec, we can see here the content name is pod A. Again, we provide the same name and the image. This is a Apache image. Okay. So whenever we are running this application, we will get a Apache web server. So that's why the image is HTTPD. And the port exposed container port is port number 80. And coming to B, we used not Apache, we use Nginx. Okay. It's another web server. And rest of them are same. C also we use Apache. Okay. So in this case, we are going to create three application. That application for web server, A and C is for Apache web server, and B is for Nginx. Okay. So I am quickly applying kubectl. See, inside the YAML, we specify the namespace. See, GS. All the application we specify the namespace GS. But coming to our cluster, the namespace is not found. So we need to create the namespace first. Kubectl create namespace, the name of the namespace, GS. Namespace is created. Again, apply. So the pod A is created. Then I am pushing b.yaml. B created, application B created. Then I am pushing c.yaml. Okay. So all the application deploys successfully. Check the pod. So it will taking the pod from the default namespace. But in our case, all pods are under GS. See, pod A running successfully. B and C. All the three pods are running successfully. So by default, each pods can talk with the I mean, pod A can talk with the B, B can talk with the C can talk with the B can talk with A, and A can talk with the C as well. Okay, all pods can talk with each other. So in this case, what we will do, we need to create a network policy for secure our pods. Our requirement is A can talk with the B, but A can't talk with the C. Got it? So similar scenario, what will you do? We need to create a network policy within Kubernetes cluster. So by default, there is no network policy inside Kubernetes cluster, okay, even EKS or manage one. So what will we need? We need to create or we need to install network policy components or services. So it's a kind of a agent, okay. We need to install the agent inside our Kubernetes cluster. So different agents are there like Calico, Flannel, then Cilium, different like network policy agents are there. So we need to install that policy, or else we can do one thing, just to go to the cluster. Kubernetes cluster. There is an option called CNI plugin, okay. Network CNI. So this is a cluster. So go to cluster. Here we can see add-ons. Click add-on. So see Amazon VPC CNI. CNI means container network interface, okay. So we just go to the Amazon VPC CNI. This is already installed. So we need to do some configuration. So click on that. Here we can see edit option. Oh, optional configuration settings. Here we can see configuration values. So here we need to add some configuration. That is enable cluster policy is equal to true. Okay. And save changes. It will take some time. Again, the plugin, I mean the VPC CNI is in progress because it's updating our new changes. So after this changes we added enable network policy is equal to, by default it's false. Now we change to true. So if we change this true, then we didn't install any third-party agents like Calico or Flannel. Successful. Then we can go to the cluster and again check and verify that is fetching effect. I mean, go to VPC. It's updating. Yes, it's active. See, under VPC CNI, it's active and we can see the advanced configuration. Enable cluster policy is equal to true. Now we can say the network policies, all the things are done inside our Kubernetes cluster. So now we need to create a policy for our requirement. Okay. So this command will showcasing the working pods are under which working node. Okay. So you can see here the application C and B in same node. This is another node. Okay. I'll showcase. See, we have three worker node. I mean, three EC2 machine. the IP comes 136, 26, and 81. These are the local IP for our nodes. Internal IPs. See. So coming to our port, this port A belongs to 93. Sorry, 81. 93 is pod IP. Okay. We have node have their own IP and pod have their own IP. Okay. So the pod A comes to 81. That means the third node. Okay. The pod B comes to 136. That means the first node. And pod C is 81. Same. So this pod is empty, I think. There is no pod under the node. Okay. Leave that in. Just showcasing. So now you can see these pods are running on different node, and the pod have their own IPs. See, these are the pod IP. Okay. So now we can check the connection between each pods. Okay. For example, the pod A can talk with the pod B, or pod B can talk with the pod C, like that. So for that, we need to create a first we need to log into the pod, then we can try to connect our ping connection. We can curl from the pods to desired port.
Topic Mahesh here again. Sorry.
Yes.
Now the pod A and pod C showing the same node, right? 81, 81.
Right.
So you just went on the AWS and you made a changes like enable. You made it enable kubectl true. You made it correct. How did it showing same? How to how to change the requirement? Like how it is showing that A and C is the same.
I mean, pod A and B. Oh, sorry, pod A and C is in same node, right? That's a
Yes.
yes. In this case, pod A and C is in the same node because that is under the job of the master node, right? So the master node assigning which pod is under which node. Got it. This is by default.
That is, it is by default.
Right.
Okay. Oh,
If
I thought it is a requirement. I thought it is a
No, not
requirement.
requirement. No.
Oh.
That's why the master part there. I mean, master part have their own duties like checking the best node there, node CPU count, node is ready for receiving deployment, like that.
Okay.
So the master node knows that the pod 2, right? Pod 81 is good to deploy one more pod, like that. So they will push the application to the same node.
Okay, in case if we create 4 pods like A, B, C, D, you mean that B and D will default will
No,
connect?
it's a like a algorithm there, checking the node and it's best. Then it push the application to the corresponding port. That's all. Sorry, port node.
Okay, it'll work as algorithm way.
Right.
Okay, got it.
For example, if we need to apply some port. Okay, another scenario. This is default. So another scenario there. We have some application. We have a YAML file, and we need to push the YAML. I mean, we need to deploy the application to the specific node. Okay, so we can set that thing inside the Kubernetes. This is default one, so it will randomly go to any node and we can see the application. Or else we can, for example, these 3 applications only deploy to node 1, I mean, or the 81 IP. So we can set that things. That's all the requirement. As per the requirement, then we can go like that. But most commonly we deploy this way, like randomly. Got it.
Yeah, got it.
So now we need to check the connectivity, right?
Yes.
Connectivity between the pods, like kubectl. Now we are going to open one of the pod, okay? Using x command, exe, then it. Then we can check from pod B, pod A. Namespace GS, then open a shell there using bin bash. See, now I am in container, okay? See the root, pod A, user local Apache 2. So now I am in a container. So from here, I am going to connect from A to B and C. Now I am in A. So now I am going to check the connectivity from A to B and C. So before that, we need to install some plugins. Okay, like sorry, no, I mean installing the curl command. By default, there is no curl command inside the container. So we need to install that thing. Apt update. This is container, okay? Don't forget that thing. Then apt install curl. Okay, now everything is fine. We successfully log into container and we created we installed our curl command for curling our required machine. Okay. So now we need to check the IPs again. Exit. Now I am exiting from the container. ODA. Okay. So now again using the kubectl. I only installed curl command in pod A. So do the same thing for pod B and C. Now log into the last pod C. This is just installing the curl, okay? So everything is fine, exit from the container. So now we can check the connectivity. kubectl exe. Now I am checking the connection from port A to port B, okay? So port A, namespace, GS, then curl. called the IP. So from A to B, I am creating a connectivity. So the B IP is, port IP is this one, 35. Copy, paste. So whenever we hit enter, we will get the data, okay? Hit enter. See, we will get the Nginx configuration data here. Doc, welcome to Nginx. See, they can talk. Do the same for Apache, okay? So I am going to connect from A to C. See, it's Apache. It works. C, we install C, Apache. A also Apache, and application B, we configure the Nginx, right? So now we can say one more thing we can check with the C2A. C2A. Application A IP address 395. It also works. Application A have Apache. So by default, now you see by default all the applications have connectivity between all the pods within the Kubernetes cluster. So we need to secure the connectivity because we need to stop the connectivity between the ports that we need. Okay. So that's why we install the network policies and create a network policy YAML file and apply within the Kubernetes cluster. So now I am going to create a policy, network policy. And for that policy, what are things we are going to do is uh, pod A, pod A to C, we need to create a connection, okay? Pod A to C, from A to pod C. But pod A to B, there is no connection, okay? So we need to create a network policy. I think that is here. Yes, the policy YAML file is also always here. We just to go to see cat p.yaml. See, this is a YAML file for application pod A. Okay, so what are things you can see here? The kind is network policy. Okay, so Kubernetes know this is a network policy, and here you can see the name of the policy is pod A network policy, and the namespace GS, same namespace. Then coming to spec controller, you can see port selector. Okay, so the match label is pod A. So which I mean, in this policy we applied for the match label that is correct with the app pod A. Okay, so this will applies this policy to pod A, and the policy type is ingress and egress. So here we coming to ingress, we from port selector match label B. So this is only the requirement is pod B. Okay, the ingress comes to the port B. Application port B. So I'm going to apply network policy is applied. Okay. Now I am going to create checking the same connection. Okay. First, I am going to check the connection from B. Okay. So from B, I'm going to access A. See, it works. Now I am going to access C. Both are work. Now changing the port. (91C). Okay. That works. Okay. All are following, right?
Yeah, basically you have the
Yes.
policy.yaml that says ingress from this pod and
I am
to
checking
this
the
pod.
connectivity.
So you can do the curl command to ping different IP addresses of the different pods, but some of them will fail because you don't have connectivity there, and that's what you wanted.
No.
So you're testing.
As of now, there is no fail, but we need the fail because otherwise our policy is not applied.
Yeah.
From B, it's fine. Now I need to check one more thing. Now I need to check from C. Okay, that's a pending one. From C, I am going to check A and B. Yes, it works. See, that means the pod C can't talk with the pod A. That's why it's still didn't get any data. See, after some time it's going to timeout. I'm just breaking. I'm checking to from C to B. Yeah, that's working. But A, we applied that only A talk with B, not C. That's a scenario here. Got it. Cat P dot YAML. Here we specify, I mean, like we applied a policy for pod A. Okay. We applied for the pod A and we specify the incoming traffic only from B. Got it. So
Not
B,
from C.
Not from C. Not from C.
But if
Means
you
no
add,
other. Only how many ports are there in n numbers of port there? I mean, only incoming traffic from port B. That's a requirement to port A.
but if you put app pod B and then you put comma pod C, then it will work, right?
Right.
So this is your network configuration.
Yes. This is Kubernetes network policy configuration.
Policy configuration. Okay.
Yeah. Now you got the idea, right? All of you.
Yes.
So I will share the record and the document. So you just try it in your environment, okay? And check the connectivity, like using the curl. Because when we go with the third party, we will face some errors like Calico and Flannel. Okay. Any doubt or anyone?
No doubt.
Then we can wind up, right?
Sure. Thanks. Have a good night and a good morning to Taufik.
Okay.
Thank you all. Good night.
Bye.
Good morning.
Bye.
So you're meeting Monday again, right?
Yes. Monday we can look into Lambda, S3 database and all the things.
Modules also.
Sorry?
Modules.
Yeah. I didn't get you, Mahesh.
I pinged you last time. We need to discuss about the Terraform modules.
Oh, modules. Okay. Yeah, I will. Yeah.
Okay.
Okay then. Yeah.
Thanks.
Bye. All.
Thank you all. Bye.
Bye, sir.
Bye.
Bye, sir.